Last few days. Now here's the thing. You've got to be able to determine the different types of factoring that you'll use because you're not going to always use the quadratic way. You're not always going to use the greatest common factor way. So I want to make sure we're keeping them separate in our minds. So everybody look up here. These are the three types of factoring we've now seen. We first seen when you have something like this, you factor out the greatest common factor. Now look, a lot of you weren't paying very close enough attention on the last assignment or on the assignment, but isn't this degree 4? So we wouldn't do a times c adds up to b. That's the way we factor quadratics. So we would say, okay, well, what are we looking at here? Let's see if there's a greatest common factor. So what's in common here and here? X cubed. So then left hand side, we would divide by x cubed, divide by x cubed. So left would be 2x minus 3. So does everybody remember GCF? Okay, then if we're looking at something like this, it's called factoring a quadratic. So we check, is it in standard form? Yes. So then we do what multiplies to be a times c adds up to be b. What multiplies to be negative 7, right? A times c. And adds up to be negative 6. What are the factors? 1 times 7, right? Wouldn't it be negative 7 so that it adds up to be negative 6? So then can we quick factor it? Yeah, our a value is positive 1. So this is going to factor to be x. That's a positive 1, so plus 1, and an x minus 7. We would do the long method, drop and break, if our a value wasn't 1. And then, now we just learned, we would not do a times c in this one. It's degree 4, but not only that, isn't there 1, 2, 3, 4 terms? We have 4 terms. If you have 4 terms, we factor by grouping. We group those two, and factor out each group. In common here is a 2x cubed, right? Left is x plus 3. Over here, there's a positive 3. So then left is 3x, right? Positive 3x. Sorry about that. And then left would be x plus 3. Then we factor out x plus 3, our safe haven. And left is 2x cubed plus 3. We're all comfortable? Okay, moving on. Okay, so last thing I want to say is when factoring quadratic, which is what we did last time, you're going to get an answer, but you need to make sure it's factored completely. So if on a test I said factor completely and you didn't, you'd get it marked halfway wrong. So look up here. On number 11, everybody look at your number 11, on 1.2. We would do a times c adds up to b. We'd go through the process and we factor, and let's say we get down to this. Now you look at your factors and say, yeah, that's right, that's great. But now can we factor even further? X minus 9, is there anything more in common? No. Well, look at 3x plus 6. Couldn't we factor a 3 out of that? And then left would be x plus 2, right? That's considered being factored completely. So we have a 3 in front, we have an x minus 9, and we have an x plus 2. Does everybody see how to factor it completely? Yes. Yes. Yes, that's what we would want to do. So good point. He makes a good point. In the beginning, it would have been just really easy to say, don't all three things divide by 3? So we could factor out a 3 in the beginning. Left is x squared minus 7x minus what? 54 divided by 3. 18, that's right. Now, isn't that easy factoring? Quick factoring. So wouldn't that have been the easier method? Factor out the 3 in the beginning. As long as you don't forget your 3 in your final answer. Good point. Okay, awesome. So what I want you to do now is go and look at all your answers on 1.2, and if they're not factored completely, you factor them completely. So if you have an answer that's like, for example, that's 25x plus 5, let's say that was an answer, and x minus 1, you would go and fix it. You say, oh, this factor factored further. So I pull out a 5, left is 5x plus 1, and x minus 1. Go look at all your answers and make sure they're factored completely. Ready, set, go. Pay attention to the little details. Are you ready? Are you ready? Are you ready? Okay, so I would have a place to take notes if I need that I can keep and refer back to if I need. I did give you a note sheet. However, I'm not following it exactly. Some of my examples are on there, some aren't. Okay, so right triangle trig. This is a unit in secondary math 2. We're reviewing it in 1 day, so we're going to fly through. Pay attention. So right triangles. First of all, you have to know what a right triangle is because in secondary math 3, we will deal with non-right triangles later down the road. But we're going to review right triangles because in secondary math 2, you only cross right triangles. So right triangles have a 90-degree angle and it's written with that little square. That means 90 degrees. What's a right triangle, guys? There is a 90-degree angle. Do you all understand that? Okay? So right triangles have a 90-degree angle. Now some vocabulary. Across from the 90-degree angle is called the hypotenuse. Okay? Then we have these other two sides. I'm just going to call this side 1, side 2. Those don't matter, side 1 and side 2. I could call this side 1 and this side 2 and that the hypotenuse. So you can find missing side lengths. These are sides. You can find missing side lengths of a right triangle by using the Pythagorean theorem. So Pythagorean theorem, a lot of teachers teach it as a squared plus b squared equals c squared. But then people get too wrapped up in what's a, b, and c. So I just state it like this. Same thing, but I state it like this. Side 1 squared plus side 2 squared is equal to the hypotenuse squared. Because it really doesn't matter. A, b, and c don't matter. But side 1 squared plus side 2 squared equals the hypotenuse squared. The important thing is that you put the hypotenuse over on that side of the equation. Does everybody understand the Pythagorean theorem? Okay, I'm going to ask you one quick question to see if you were paying attention a second ago. If I gave you this triangle and I gave you a 4 and a 3, and I said, find this side, would it be appropriate to use the Pythagorean theorem? No, right? There's nothing saying this is a right triangle, right? So we're going to learn later in the year how to do that. That's actually, a lot of people miss that on their ACT. Okay, awesome. You guys understand. Okay, here we go. 1A. Here's our example. We're finding x. Now look, we have two other sides, so we can go ahead and find x. Pay attention though. You have to be careful. This is our hypotenuse, right? So we're going to do one side 1 squared plus side 2 squared is equal to the hypotenuse squared. So side 1 squared, it could be x or it could be 5. It doesn't matter. I'm just going to go with x squared. That's side 1 squared plus side 2 squared. The other side is 5. And that's equal to the hypotenuse, which has to be 9 squared. We all comfortable? So now it's just algebra. X squared plus 25 is equal to 81, yeah? So then we're going to try to get x squared alone. So we would subtract 25 from both sides of the equation. So we have x squared is equal to what? 81 minus 25. What is it? 56. Now, guys, keep in mind, a lot of students stop here. We don't want x squared, we want x. How do you want to do the square? Square roots. Now look, roots cancels out with power. We have x is equal to the square root of 56. Everybody type that into your calculator. What do you get? 7.48. Now guess what? In secondary math 3, it is not acceptable to have a decimal answer. In secondary math 2, it's not acceptable to have a decimal answer. Teacher lecture, they should be slapped. We have to have exact answers. You will not see a decimal answer on an ACT. So we will break this down by hand and simplify that square root so that we have an exact root. But we have to have it in the simplified form. So what are some factors of 56? 8 times 7. 8 breaks down into 4 times 2. And 4 breaks down into 2 times 2, right? Now, I call this double dipping. Students tend to double dip. They think that there's an 8, a 7, a 4, a 2, a 2, and a 2 under there. Wrong. 8 can be written as 4 and 2, right? So there's not an 8 there anymore. We rewrote it. Does everybody understand what I'm saying? 4 is not there anymore. We rewrote it as 2 times 2. I cross those out so I don't double dip. Now, we're pulling out groups of 2 since it's a square root. So we can pull that out. Now, you're only pulling out a 2 for those two 2's because listen, you're technically taking the square root of 4, which is 2. Do you understand? If there's 2 of them, they can leave the house. So you don't pull out a 4. We took the square root of 4. So we just pull out a 2. Does that make sense? So we pull out a 2 for those two 2's. We can't pull that 2 out. There's not 2 of them. We can't pull that 7 out. There's not 2 of them. So they're left underneath the square root. So you multiply them back together. 14. 7 times 2 is 14. Now, if I would have pulled out another thing, like let's say I had a 3 and I had 2 3s and could pull out a 3, we would multiply 2 times 3, not add. There was no addition sign anywhere in here. It's all multiplication. Does everybody understand that x is 2 square roots of 14? That's the only acceptable answer in secondary math 3. Okay. Looking at 1b, here we go. So we're going to use this to find the missing side. Here's our hypotenuse. So we know that side 1 squared plus side 2 squared is equal to the hypotenuse squared. Side 1, I'm going to go with x squared plus side 2, which is 8 squared, is equal to the hypotenuse, which is the square root of 197, all squared. Now it's algebra. So we have x squared plus 64, 8 squared 64, is equal to, root cancels out with power. What's left? 197. Now it's solving for x piece by piece algebraically. Subtract 64. Somebody give me that. Somebody give me that. X squared 133. We're not done. We have to take the square root. Now let's see if there's factors. So you take your calculator, 133 divided by 2, divided by 3, divided by 4, divided by 5, divided by 6, divided by 7. You test a bunch, and there's no factors. So we would leave our answer at the square root of 133. That's an exact answer, which is much better than a decimal. Questions? Ready to practice? Go for it. Now. Okay. So now there are times when you're not going to be able to use the Pythagorean theorem because you have to have 2 sides to use that, right? Everybody? So there are times when you can't use the Pythagorean theorem, and that's when you resort to right triangle trigonometry. So there are 3 known and popular 3 right triangle trig ratios. It goes sine of theta, cosine theta, tangent theta. Now understand something, theta is the angle, and theta can go in any place other than the 90 degrees. So look at my picture, everybody. Here's theta in this angle. Does everybody see that? Yeah. Okay, for theta being in this angle, this is the opposite side. You see how straight across would be opposite. Hypotenuse is always across from the 90 degrees. And adjacent will be sitting right out to the side. But you can always find adjacent easy because opposite's easy, hypotenuse is easy. Do we all understand from this theta? Okay, now sine theta, cosine theta, tangent theta. This is the saying that I use to help me remember sine theta, cosine theta, tangent theta. So it goes in that order. You'll have to memorize sine theta, cosine theta, tangent theta. But then the saying goes, oh heck, which stands for opposite over hypotenuse. Oh heck, another hour of agony. Oh heck, another hour of agony. Some people feel that way. Yep, I'll write that down next. So let's all practice that. You can use either or. So sine, cosine, so sine theta, cosine theta, tangent theta. Let's all say the same. Oh heck, another hour of agony. So adjacent over hypotenuse, opposite over adjacent. Another popular thing that's used, which is just as good, it's called SOHCAHTOA. So, sine opposite over hypotenuse, cosine is ka, adjacent over hypotenuse, and toa, opposite over adjacent. Tangents opposite over adjacent. You're going to hear me use this one's just as good. Okay? Okay, I want you to know one thing, though. This is important. You will all have something where you'll have a right triangle trig problem on an ACT. Here's what's important. We're going to be calculating things, and we're going to be plugging in degree thetas. Your calculator has to be in degree mode. Everybody pull up your graphing calculator. Because we're going to be plugging in degrees, your calculator has to be in degree mode. So everybody hit mode. Everybody right here, mode. Yep, if yours is already in degree mode, it's good. So see how most people's will be in radian mode? Scroll over to degree mode and hit enter. Now it's in degree mode. Now I need you to understand something. If your calculator is in degree mode and you're calculating like 2 divided by 3 or anything algebraic, it won't affect you. So you can leave it in degree mode for the most part all the time. Does that make sense, everybody? So you would want to make sure it's in degree mode or else it's going to not calculate these correctly. You have to remember that for your ACT. Okay. So here we go. Look up here. You don't need to take notes. Just look. Okay? It says find sine of A. So this means we're going to go to angle A. Does everybody understand that? Here's angle A. So sine is, oh heck. So from angle A, we're doing opposite over hypotenuse, which would be 3/5. You all understand that? Yes? Now it says find sine of B. We've got to go to angle B. Sine is still, oh heck. So that would be, oh heck, 4/5. Does everybody understand that? And cosine of A, we go to angle A. Cosine is another hour. So adjacent would be 4 over hypotenuse, which is 5. Cosine of B, we're going to angle B, and it's adjacent over hypotenuse, so that'll be 3/5. Do you guys see how to do this? Do I need to do tangent, or are we good? Right, it's just, we're just looking at and comparing trig ratios. Okay, sweet. Here we go, looking at 2A on the, if you want to do it on your little paper. So it says find tangent of theta. So theta's right here, tangent is opposite of agony, opposite over adjacent. Here's theta, opposite is 12, over adjacent is 16. So that's 12 over 16. Now I want you to pull up your graphing calculator. I'm going to teach you this now. Let's say you wanted to put that in the most simplified fraction. Your calculator will do it for you. Even if you can do it by hand, learn this, because your calculator will make sure you get it right. Everybody get out of there, do second quit, type in 12, divided by 16 with me, hit enter. Now you get a decimal. Decimals are not acceptable in this class. So you'll hit math, enter, enter. It says, want to put me in a fraction? Yes. So math, enter. Oh, 3/4. Okay. Let's do another one. Sine of theta. This one's important. Guys, this one's different, and there's too much talking when I'm teaching. Let's get through this quick, but look up here. Sine of theta. Sine is, oh heck. Now look. Oh heck. Crapola. Do we have that? No. But can we use Pythagorean theorem? That's why I never figured it out. So now we're like clicking, okay, that's why we have the Pythagorean theorem. Side 1 squared, 15 squared, plus the other side squared, 20. It's 20 squared is equal to the hypotenuse, which happens to be question mark squared. Right, I did this on purpose to help, yeah, because of that reason. Okay, so even though I gave it to you on the paper, hey, you over there, I can hear you talking. It's driving me insane. Okay, on your paper, I gave it to you, but a lot of times on a test, I wouldn't. I'd have purposely not to see if you could make the connection. Did you make the connection? Okay, so what is this? Go, tell me. 15 squared plus 20 squared. 225 is equal to question mark squared. Before you start breaking it, so then we'll take the square root. Before you break it down, just see if it's a perfect root. Take the square root of 225. 15 is equal to question mark. So are you sure that's 15? Oh, yeah, you're right. Hey, what? You're right, that's not right. Can somebody calculate that for me? The quicker you are, the quicker we get through it. Go. Yep, it's 625. It's equal to question mark squared. Then we would square root both sides. The square root of 625, tell me. It's 25. If we got a decimal, we'd break it down by hand, right? Now we know. So this is 25. I have people put that as their answer. No, that was just to be able to do opposite over hypotenuse. Opposite is 15, right? Over hypotenuse, which is 25. Go, calculate it on your calculator. Give me the simplified fraction. You type that in, hit math, enter. Let's practice that. 3/5. Good. Okay. Do I need to do another one, or are you ready to go? You're ready? What about number 5? Do you want me to do number 5 with you on your worksheet? No? You're good? Okay, go for it. Okay, you really need to pay attention or you're going to be a lost soul. So it says, use the trig ratio to find the missing angle. So now look up here. Do you see how we're finding this angle? This is how you'll do it. You'll look at your picture. You'll set up a correct trig ratio. based on the information you're given, and then you'll solve, and I'll show you how. So we need to find this angle. From this angle, aren't we given the adjacent side? And we're given the hypotenuse. Which one uses adjacent and hypotenuse? Cosine. So we know a trig ratio of cosine theta is equal to adjacent over hypotenuse. So we really have cosine of theta is equal to adjacent, which is 2 over 7. Does everybody understand that part? Now look, this is where people get confused. If we have cosine of theta is equal to 2 over 7, are we trying to get theta alone? Right? Yeah. It's trapped inside cosine. It's trapped inside cosine. So the only way to get this cosine to go away is to take the cosine inverse. You got to do that to both sides of the equation. Now look at that. Cosine inverse undoes cosine. That's what inverses do. They undo. So we have theta is equal to, and over here we have the cosine inverse of 2/7. Now you'll just type it into your calculator. Pull up your calculator. Good. You'll hit second cosine. So second cosine of 2 divided by 7, hit enter. 73.4. Let's round it 1 decimal place. Theta is equal to 73.4 degrees. That angle is 73.4 degrees. Questions? Okay. Okay, here we go. Number 11. Let's do it together. This is different. I can't focus if people are talking. Let's do number 11. So, notice, we're going to find this x, but notice something. Okay, we have a right triangle, we need to find x, but we can't use Pythagorean theorem, right? So we're going to use right triangle trig. So look up here. Do you see how we're given this angle? So we're going to use that angle as theta. From that angle, we've got to set up a correct trig ratio. So from theta, we have opposite, right? And we have adjacent. Which one uses opposite and adjacent? Oh heck, another hour of agony. Tangent. So guys, pay attention. Tangent of theta is equal to opposite over adjacent. Now we're just plugging in what we know. We have tangent of not theta. Don't we know theta? 44.8. And that's equal to the opposite side, which is 5, over x. Isn't that a true statement? Now we've got to use correct algebra to get x alone. How would we get x alone? Now I'm going to ask you a question. Isn't the x on bottom? Yes. How do you want to do division? Multiplication. Yes. So we're going to algebraically multiply both sides by x. So we have x, tangent of 44.8 is equal to 5. Is x alone yet? Nope, we have another step. When we divide both, okay, it's x times tangent of 44.8. One does multiplication, division, right? So we'll divide, well, yes or no? Tangent of 44.8. We'll divide both sides by tangent of 44.8. Now looky look. Those divide out to be 1. Is an x alone? X is equal to, do we all understand? X is equal to 5 over tangent of 44.8. Type it into your calculator. 5.03, this is rounded to the nearest tenth, so we would say x equals 5. Does that make sense? Yeah. Question? Do another one off your worksheet to lighten your load. Number 12. Okay. Find the missing piece of information. We can't use Pythagorean theorem, but we do have an angle. We have a right triangle. We have one other side. So I'm going to use 65 as theta because that's all we have here. We're going to have the opposite side and we have the hypotenuse. Oh heck, right? Sine. So we know sine of theta is equal to opposite over hypotenuse. Let's plug in everything we know. Sine of 65. Isn't theta 65? Is equal to opposite, which is x, over hypotenuse, which is 16. Now the algebra is different on this one, right? We're trying to get x alone as our goal. So how am I going to get x alone? Good. 16's on bottom. We need x alone. We're going to get rid of the fraction, so we're going to multiply both sides by 16. So we have 16 sine of 65 is equal to x, because don't those divide out? Have we reached our goal? X alone? So calculate it.
Yeah. There it is.
14.5. Okay, last one. The rest of the time will be yours to practice. We are going to round to the nearest tenth, which means 1 decimal place. Here we go. 13, last one. Find the value of the missing piece of information. So the missing piece of information is theta, right? So let's set up a correct trig ratio. We have the opposite side. We have the hypotenuse. Oh, heck. Sine of theta is equal to opposite, 15, over hypotenuse, which is 16. Oh, we're trying to find theta, though. We need to undo theta because it's trapped inside sine. So we're going to take the sine inverse of both sides of the equation. Sine inverse undoes sine, which drops theta down. And we're left with sine inverse of 15 over 16. Type it in. Okay, sweet. So that theta is 69.6. Questions? We're all good. You feel good about right triangle trig. This is an entire unit from secondary math 2 in 1 day. Wow. Good. That's what I like to hear. Finish the worksheet.